Hi guys, today with my another video I'll illustrate to you that it is a very important concept that any charge which is given to a conductor always flows to the outermost surface of the conductor. And why this happens, I'll illustrate you with an example. Okay, so I've already drawn the diagram and I've taken two concentric spheres. Concentric means their center is same. Now, one sphere has a radius A, other sphere has a radius B. Here B is greater than A, and I have given a charge, positive charge, to the smaller sphere Q1, and I have given a positive charge Q2 to the bigger sphere. Now, let us write the potential first. Initially, we have also a provision of grounding. In fact, the provision of connecting these two spheres. So, by a switch K. So, initially, first we write the potential of inner sphere. So, while writing the potential of inner sphere, the potential on inner sphere will be due to two spheres, due to that inner sphere itself as well as due to that outer sphere. So the potential on inner sphere due to itself would be K Q1 by A. I hope you know how to distribute the potential on spheres, or how to write the potential of spheres. Or if you don't know, I'll be coming with more videos to demonstrate that, but that would be at the later part. So in this part, the potential of inner sphere is K Q1 by A due to itself, plus potential on the inner sphere due to outer sphere. Potential on inner sphere due to outer sphere. So first of all, let me write some formula here. We know that the potential due to a sphere, conducting sphere, inside it, V inside, is KQ by R. Inside the sphere at any point, the potential is KQ by R. V on surface is also KQ by R, and V outside the sphere is KQ upon small r, where small r is the distance of that point from the center of the sphere. So it is important to note that when we write the potential due to a sphere inside it or on its surface, then this factor is the radius, and when we write the potential at any point which is lying outside the sphere, then this distance, this factor is the distance from the center of the sphere of that point where we wish to calculate the potential. So now first of all, I am repeating myself that while writing the potential of inner sphere, the potential of inner sphere will be due to itself plus potential due to outer sphere. So potential of inner sphere due to itself would be K Q1 by A, as well as due to outer sphere it would be K Q2 by B. I've already written that potential due to any sphere inside it is dependent on its own radius. So potential of bigger sphere inside it would be dependent on the radius of bigger sphere and the charge of bigger sphere. Now, V outer sphere. Potential on outer sphere. So potential on outer sphere will also be due to potential of that outer sphere due to itself, as well as potential of outer sphere due to inner sphere. So first we are writing potential of outer sphere due to self or due to itself. So potential of outer sphere would be KQ2 by B due to itself, and potential of outer sphere due to inner sphere. Now it is important to note that any point of outer sphere is lying outside the inner sphere. So while writing the potential outside, we have to take the distance of the point from the center of the sphere and not the radius. So the potential of outer sphere due to inner sphere would be kq1 by distance of that point which is lying on the surface of outer sphere from the center of inner sphere is b. This distance is b. So we will take b. Now let us assume that v inner is greater than v outer. Let v inner is greater than v outer, and therefore delta v is equal to v inner minus v outer. So v inner will be k q1 by a plus k q2 by b minus v outer k q2 by d. I am erasing this thing. Minus k q1 by b. So cancelling this out, delta v is equal to, taking k q1 common, 1 upon a minus 1 upon b. Now there is two important things here, that delta v potential difference, delta v is positive. Obviously q1 is positive and a is greater than, in fact b is greater than a, therefore 1 upon a is greater than 1 upon b. So this term comes out to be positive, which means delta v is positive, which also means that the fact v inner is greater than v outer. So I have assumed the v inner to be greater than v outer is absolutely correct. So we know that when we connect, when k is closed, then positive charge always flows from higher potential to lower potential. Positive charge always flows from higher potential to lower potential, and in this case higher potential is that of inner sphere. So when we connect these two spheres, charge will flow from inner to outer sphere. And how much? Till charge flows from inner to outer sphere, till delta v becomes 0. Now how can delta v be 0? There are two possibilities, out of which one possibility is not possible, that 1 upon a cannot be equal to 1 upon b, as the radius of these two spheres is not variable. In fact, a is lesser than b, therefore 1 upon a is greater than 1 upon b. They cannot be equal. And another possibility is the fact that if q1 becomes 0, if this charge q1 becomes 0, then delta v can be 0. So by this I can conclude that delta v will become 0 after the complete charge q1, which is on the inner sphere, will come on the outer sphere. I am repeating myself that there are two things. Charge always flows from higher potential to lower potential. This is the first thing. And the other thing is the fact that the potential difference between these two spheres is dependent on the charge on the inner sphere. This potential difference is dependent on the charge on the inner sphere. So till the charge on the inner sphere becomes 0, or I can say till the complete charge on the inner sphere comes on the outer sphere, the charge will keep on flowing. And as soon as the complete charge appears on the outer sphere, then the delta V, change in potential, will become 0. Potential difference will become 0. And if potential difference becomes 0, then no charge will flow further. So till delta V becomes 0 and till Q1 becomes 0. And how Q1 is becoming 0? Q1 is in fact not vanishing, Q1 is flowing from inner to outer sphere. So finally the diagram will be like this. The complete charge Q1 plus Q2 will appear on the outer surface of outer sphere. I hope this is a mysterious concept and this is a reason of panic for most of the students. I hope you understand the concept, and this is very important as far as JEE Advanced is concerned. So I hope you liked the video and keep watching for more interesting and unique facts of physics.